Hi, I'm Ahmed Osama, and I'm going to talk about our embedded systems project. And we tried to succeeded in implementing an electronic Enigma, and we've dubbed it el-Helaal Enigma. Okay, so first I'm going to describe how Enigma works. Given an input, it takes an input by the keyboard. It goes into a plug board, which maps a letter to a different letter, and internally it has three different rotors. Each rotor maps this letter to a different letter. If T is mapped to A is mapped to W in the first rotor, W to F, F to Q, and then the reflector is static. These change. This one doesn't ever. So Q is mapped to D, then it goes back through the rotors and through the plug board, and it outputs a completely different letter. Each time a letter enters Enigma, this rotor is incremented by 1. It moves one more displacement, and until it makes a complete rotation. When it completes a rotation, this one is incremented by 1, and so on and so forth. And when this completes a rotation, this one is incremented by another displacement. This is how Enigma works. Okay, so let's take a look. And of course, the two Enigmas, if we want to decrypt this, the other Enigma machine that is going to decrypt has to have the same initial configuration, the same initial displacements for the rotors, and the configuration of the plug board to be able to decrypt this message. Okay, so this is our first Enigma machine. This is the second. They are connected with serial wires, and of course we have entered the same configurations. So let's see if it can. This one can decrypt what this is going to encrypt. Let's just maybe enter. So this is the encrypted message. We send it. It's sent through the wire, and it's received, and then it's been able to be decrypted. If we try to if we reset one of the Arduinos, it goes back to the initial configuration. But this one's configuration has changed due to letters entering this Enigma. So if we try to send another message, say 1, it gets encrypted, and this is the encrypted message, but the Enigma machine is not able to decrypt it because the configuration has changed. And it also can work without serial connection, but of course we have to just 1 moment. Okay, so now the two Enigmas are disconnected. We have to reset both for both of them to have the configuration. If I say 1 again, maybe 1. So this is the encrypted message. I'll take it right here. PVQ. Go to the other machine. Write the encrypted message. PVQ. And it gets decrypted to 1 again.
Hi, I'm Ahmed Nader, and I was responsible for the hardware configurations in our Enigma project. So to begin with, the keypad connections, there were 8 wires connected to the keypad, connecting the 4 rows and 4 columns for the keypad, and going all the way to the Arduino in the digital pins for the Arduino. And we had also the LCD screen, which we used to display the characters, which were encrypted and decrypted. And it also needed 4 pins we used from D4 to D7, 4 pins over here, and connected to the Arduino. But we had used the analog pins also for our connections, as the digital pins were not enough for our connections. So we used the analog pins instead. And then we also connected we had 4 other pins, the enable pin, which enables to the input characters, and the read write, and the VSS and VDD, which were the ground and the 5 volts. And to connect the LCD, we needed 250 ohms resistors, so we connected 4,000 ohms resistors in parallel to get the 250 ohms required. And then we also needed a variable resistor, which without it our LCD was not working. So that variable resistor is connected to the V node for this LCD, and that was to control the contrast for the LCD. And we also connected both Arduinos by connecting the TX for the first to the RX of the second, and the other way around, the TX of the second to the RX of the first. And we also used the common ground for both Arduinos to make communication between both sides.
Hi, my name is Sherief. I implemented the keyboard in this project. It's actually a keypad. We use a library called keypad.h. The library takes the indices of the pins we used to connect the keypad to the Arduino, and a character for each key, for each of these keys. Whenever we want to enter a letter, we can, if the letter is the first and on the key, we just press the key. If we want to enter the second letter, we press one of these 3 modifier keys. For example, to enter B, press F1 and B. To enter a space, we use 0. And you see there is a space entered. And finally, when we before that, when we want to erase everything we've written, we can press cancel. And when we finally want to send whatever we wrote to the Enigma encryption code, we press enter.
Hey, I'm Mayada Mohamed, and I handled the LCD and serial input-output in our project. So basically I used the liquidcrystal.h library, and if you're the one sending a message on the Enigma, it prints out the characters using LCD to print each character until you press enter, and then it starts encrypting, and the cursor moves down to the next row and it prints out the encrypted message. And if you're the one receiving, it loops over the serial input until it reaches the terminating character, which is 9, which is appended to the string you sent. It is 9 actually. So, and it displays the encrypted message and moves down to the next row and prints out the decrypted message.